Welcome to the lecture series of Embedded Controller. We are seeing how to program in C18 in the PIC microcontroller. So today we are going to discuss the topic logical operation in C. So it is one of the most important and powerful feature of the C language, and it is ability to perform bit manipulations. So we know that logical operations depends on AND or XOR, NOR, invert, etc. So how we are going to implement those logical operations in embedded C. So that is what the concept we are going to see now. And so this is the bitwise logical operators for C. So AND, OR, XOR, and inverter. So this is the thing. So for AND we are using this ampersand symbol, and for OR using this standing line, and for NOT it is an exclamatory mark. So if it is cap, then it is indicating the XOR, and if it is a tilt that is like a sine wave, then it is an inverting option. So shift right and shift left is the most important concept in logical operation. So if I want to shift the bits of several bits of the particular number to your right or left, we can use these symbols. So for example, if 0x35 and 0xff means, so the 0x35 is bitwise and operation with 0x0f. So 35 indicate as 0, 0 and 1, 1. This is 3. And 5 is 0, 1, 0, 1. So this is 0x35. And 0x0f, that is 0, 0, 0, 0 and 1. F means 1, 1, 1, 1. So you have to make the AND operation between these two. So 1, 1, you will get 1. So this is 0. This bit will become 1. And this is 0. This is 0. This is 0. And this is also 0. So if any one of the input is 1, then my output will become 1. Otherwise, the output will become 0. That is the truth table of AND operation. So that is followed here. And if it is R, then if any one input is true, then automatically the output will become 1. Otherwise, the output will become 0. So similarly, XR means, so if both the inputs are same, then the output will be 0. So if for 0 and 0, the output will be 0. So and 1, 1, the output will be 0. If it is 1, 0, then the output will be 1. Otherwise, the output will be 0. If any one bit change, then the output will become 1. Otherwise, the output will become 0. That is the truth table of XR. And this tilt symbol, that is invert. So wherever the option present, it is, so that is 1, then automatically if wherever that is 1, then automatically it will make it as a 0. Otherwise, it is make it as a 1. Okay, so this is the changes that we are going to see in logical operations. So bitwise operators in C, there are two bitwise operators. One is shift right and another one is shift left. So shift right. So shift right in the sense, this is the arrow mark that is indicating, and shift left in the sense, this is the arrow mark that is indicating. So 0x9a, then so if this is the case, then you have to shift the numbers to 3. Shift numbers 9a to 3. So you just add right shift. So you have to shift one by bit 1 by 1 to 3 times. So if this is the case, then bit 1 by 1 to the left 4 times, and this is the case, bit 1 by 1 left 4 times. So you will obtain the answer like this. So now let us move on to the example. Write a C18 program to toggle all the bits of port B and port C continuously with 250 milliseconds delay using inverting operation. So far we have seen the same example, that is to toggle all the bits of port B and port C continuously with 250 millisecond delay using for loop. But here the same program we are feeding inverting operation, because in port C and port D we are just sending the value as 0x55, and after 250 milliseconds we are just sending 0xAA. That is then the previous case. Now we have to use inverting operator. So instead of releasing the value as 0xAA, just we apply port B equal to invert port B, then automatically the values get toggled. That is the advantage of using logical operation. So here see the example. So port B is now assigned as 0x55. So tris B and tris C, actually the port B and port C is continuously to be toggled. So my port B and port C are termed as output. So I am making tris B and tris C as 0. This is the direction register to make port B and port C as output. So now the port B, port C has output and is ready to receive the number. So I am feeding the number to the port B as 0x55 and port C as 0xAA. So two numbers I am sending. Now I have to invert these numbers after 250 milliseconds. So port B, now it is using the inverting operations, port B and port C equal to invert port C. So now what will happen? 0x55 means 0101. That is, I'll take a pen. So 0, 1, 0, 1. Again 0, 1, 0, 1. So this is your 5. Now if you are toggling, what will happen? 1, 0, 1, 0. This bit will become 1. This bit will become 0. Again 1. Again 0. So this is the toggling case. So now port B is getting toggled by providing this inverting symbol. So this is your inverting symbol. Similarly, port C also getting inverted. So what is the value in port C? That is AA. That is 10. This is the value 1010 1010. Now if you are applying invert to port C, what will happen? This one will become 0. This 0 will become 1. Again 10 0 1 0 1. Now the port B value became 5 and port C value, the port B value became AA from 5 and port C will value became 5 to AA. Then after 250 milliseconds, it will repeat. Okay. So this is the operation using inverting. So now this for loop is used to produce the delay of 250 milliseconds. So this is one case. And now the same program, write the C18 program to toggle all the bits of port B, port C, port D continuously with a 250 millisecond delay using the XR operator. The same 250 millisecond delay can be given using the XR operator. So you just see whatever you are doing in the XR operation with FF, then automatically will become the inverter. So the port B, if you are doing with F1 FF in the sense 1 1, all the bits are 1. So my 8 bits are 1 1 1 1 1 1 1 1. So these are my 8 bit, and my number actually in port B is 0x55. So 0 1 0 1. Again 0 1 0 1. So if you are doing XR operation between these two, what will happen? XR means if the two inputs are same, then the output will be 0. So this will become 1. This will become 0. This will become 1. This will become 0. This will become 1. This will become 0. This will become 1. Now check me. The port B value is 5. and now after making with the XR operation, it is changed as 10101010. So it is AA. So now it is getting inverted. The same inverting operation, that is toggle operation using XR, is also possible. This is the logical operation. So similarly, we can do the bitwise operation. So far, we have seen the bitwise operation. So similarly, we can do the bitwise operation only by RB0 and RC7 alone. So that is bitwise operation is also possible by making use of this inverting operation. So this is about the logical operations. So hope you understood.